Hari Om. In a lecture 8 of class 9 mathematics chapter number system, I explained about a rationalization of irrational number. Now in the lecture 9 of a class 9 mathematics, I am going to explain about laws of exponents for real numbers. Now begins with the first one. Let a is greater than 0 be a real number and m and n be a rational number. Then the first one is a to the power m into a to the power n equals to a to the power m plus n. It means that when the bases are same, we can add the powers. That is, example, if a to the power 2 into a to the power 2 to the power 2 into 2 to the power 3 is there, here the bases are same, 2. Now we can add the exponent, that is 2 plus 3, then it will become 2 to the power 5. This is the first law of exponents. Then moving to the second one, this is explains about the power of a power, that is a to the power m whole to the power n is equals to a to the power m into n. For example, 2 to the power 2 into whole to the power 3. Then we can multiply the powers of power, that is 2 into 3 6. Then we can write 2 to the power 6. This is the law of exponents, that is the second one. Then moving to the third one, this is a division of a powers, that is when the bases are same and in the form of a division, then we can subtract the powers, that is a to the power m divided by a to the power n equals to a to the power m minus n. It is possible when the power of the numerator is greater than the power of the denominator. This is the condition, that is when m is greater than n. Example, we can give an example for this third laws of exponent as, that is 2 to the power 3 divided by 2 to the power 2. Then here the power of the numerator is 3 and power of the denominator is 2. That is, the power of the numerator is greater than the power of the denominator. Then we can write like that, 3 minus 2. Then it will become 2 to the power 1. This is the answer. This is example of a laws of exponents for third one. Then moving to the fourth one, a to the power m divided by a to the power n equals to 1 by a to the power n minus m. This is possible when the power of the denominator is greater than the power of the numerator. Example, if you take like that, 2 to the power 2 divided by 2 to the power 3. Here the power of the denominator 3 is greater than the power of the numerator 2. Then we can write 2 to the power 3 minus 2, that is 1 by 2 to the power 1. This is the laws of exponent, that is example for laws of exponents of the fourth one. Then moving to the fifth one, a to the power m into b to the power m equals to ab whole to the power m. It means that when the bases are different but the powers are same, then we can multiply the bases. Example, 2 to the power 3 into 5 to the power 3. Here the bases are different, 2 and 5, but the powers are same, 3 3. At that time we can multiply the bases, 2 into 5 10 whole to the power 3. This is the example for the laws of exponents for the fifth one. So these are the main 5 laws of exponents for the real numbers, or some other numbers are also. Now there are few more points are there which are necessary to solve the problems of a laws of exponents for real numbers. So let's discuss those also. The first one is a to the power 0 equals to 1. It means that the power of any number is 0, then the value will be 1. And the second one, if the power of any number is a negative, then to make it as positive, then we need to bring it to the denominator, or we can write in the form of p by q, that is the number should be bring into the denominator, that is a to the power minus n equals to 1 by a to the power n. Then moving to the third one, nth root of a can be written as a to the power 1 by n. Then moving to the fourth one, n to the power a, nth power of a whole to the power m can also be written as nth root of a to the power m, that equals to a to the power m by n. To explain this one, we can write the example as cube root of 4 whole to the power square, that is 2, equals to this, whatever we will return in the root we can return as a power, that is 4 to the power 1 by 3 whole to the power 2. Then here we can use the laws of exponent, the second one, that is the power of a power. Then we will multiply both power of 4 and the whole power, then it will become 4 to the power 2 by 3. Then moving to the last one, cube root of a can be written as a to the power 1 by 3, and fourth root of a can be written as a to the power 1 by 4. So these are the laws of exponents for real numbers and some important points regarding the laws of exponents. Now after this we will solve some problems related to the laws of exponents from the NCERT textbook. The question is find the value, that is find the first one 64 to the power 1 by 2. Now find out the value of 64 to the power 1 by 2. So in the solution write the first as it is the given one. 64 to the power 1 by 2 can also be written as a under root of 64. That is square root of 64 is 8. So this is the answer of 64 to the power 1 by 8. It can also be written as, or we can solve like this. 64 to the power 1 by 2 can be written as 64 can also be written as 8 square, then whole to the power 1 by 2. Now here we can use the formula, that is power of a power, then it will become 8 to the power 2 by 2. Here we have used the formula 8 to the power m whole to the power n equals to 8 to the power m into n. Then these two get cancelled, then remains 8 to the power 1. Then any number to the power 1 is the number itself, then the value will become 8. So this is also another method of solving the same problem. Then moving to the second one, 30 to the power 1 by 5. Let's solve this one. So in the solution first write the power given number as it is, and now it can be written as by using this note. There our cube is there, here it is given fifth root, then it can be written fifth root of 32. The fifth root of 32 is 2, the answer. Or it can also be solved or written as 30 to the power 1 by 5. It can be written as 2 to the power 5 whole to the power 1 by 5. Again here also we can use the same formula, power of a power, then it can be written as 2 to the power 5 by 5. Then 5 get cancelled, remains 2 to the power 1, then 2 to the power 1 is 2. This is the answer. Then moving to the next one, (125 to the power minus 1 by 3). Solution. In the solution write once again the given one minus 1 by 3, that is 125 to the power minus 1 by 3. Here the power is negative, therefore we need to make it as a positive first. So bring into the denominator to make it as a positive. Now it became a positive. Then after it can also be written as 125, that is it is cube root of 125, and we know that the cube root of 125 is 5. So this is the answer. Or it can also be solved like this, 125 to the power 1 by 3. It can be written as 5 to the power 3 whole to the power 1 by 3. Again here we can use the formula power of a power, then it can be written as 5 to the power 3 by 3. Then 5 to the power 3 by 3 is 1, that is 5 to the power 1, and the 5 to the power 1 is value 5, 1 by 5. So these are the some problems related to the first laws of exponent. Then moving to the next problems of the laws of exponent. The next problem is 30 to the power 2 by 5. Now here we will use a formula, that is the whatever the fourth one note I have written, that we are going to use over here. First write the given problem as it is, 30 to the power 2 by 5. Here the power 2 by 5, in the power the denominator indicates the root of the 32. So it can be written as fifth root of 32 whole to the power 2. And we know that recently in this, that is just now we have solved that the fifth root of 32 is 2, then whole to the power 2 as it is, and 2 to the power 2 is answer is 4. So this is the answer of the fourth problem. Then moving to the next one, that is 16 to the power 3 by 4. Then write the given problem as it is. Then this also can be written like this, that is fourth root of 16 whole to the power 3. The denominator in the power indicates the root of the given number, and the numerator will be the power of the whole number. Then we know that the fourth power of 16 is a 2 whole to the power 3, and 2 to the power 3 is 8, because if you multiply 2 3 times you will get a 8 answer. Then moving to the next problem of the same kind, that is 2 to the power 2 by 3 into 2 to the power 1 by 5. Now here, if you want to solve here, just look at the problem given here, 2 to the power 1 by 2 by 3 and into 2 to the power 1 by 3 here. Now the bases are same, then we need to apply the first laws of exponent. That is, when the bases are same, we need to add the powers. Though that here the bases are same, we can add the powers. Let's add the power. 2 to the power 2 by 3 into 2 to the power 1 by 5 equals to 2 to the power 2 by 3 plus 1 by 5. And here look at the powers. Here in the powers are in the fraction, and we know that how to add the fractions. To add the fraction, here the denominator must be same, but here the denominators are different. So if the denominators are different, we need to take the LCM. Then the LCM of 3 and 5 is a 15. So that what we are going to do means 2 to the power, to make it as a 15, we need to multiply this by 5 and this by 3. Then it will become 2 to the power 10 plus 3 divided by 15 will be the answer. Now it can also be written as 2 to the power 13 by 15 is the answer of this problem. Then moving to the next problem of the laws of exponent, that is using a third law of exponent, that is division. Problem number 7, 11 to the power 1 by 2 divided by 11 to the power 1 by 4. Now solve this one. Here the given numbers are in the form of a division and the bases are same. When the bases are same and are in the form of a division, then we need to subtract the powers. Here 1 by 4 is greater than the 1 by 2 is greater than the 1 by 4. Therefore we can use the third law of exponent, that is m minus n. So let's write the given problem first as it is. Here we know that 1 by 2 is greater than 1 by 4, then we can write 1 by 2 minus 1 by 4. Here we have used the formula a to the power m divided by a to the power n equals to a to the power m minus n, where m is greater than n. This law of exponent we have used over here. Just now I explained that to add or subtract fractions, the denominator must be same. Here the denominators of the fraction are not same. Again we need to find out the LCM. LCM of 2 and 4 is 4. Then we need to multiply this by 2, the whole fraction by 2. Here we need not necessarily to multiply by any number, just we need to multiply by 1. Then the number value will become, here it will become 2 by 2 minus 2 by 4, 1 by 4. The denominators become same, then subtract the numerators. 2 minus 1 divided by 4, it will become 11 to the power 1 by 4. That is, the answer of the given problem is 11 to the power 1 by 2 divided by 11 to the power 1 by 4 equals to 11 to the power 1 by 4 is the answer of this problem. Then moving to the last problem of the laws of exponent, there we are going to use the fifth law of exponent. That is the problem number 8, that is 5 to the power 4 into 6 to the power 4. Look at here the given problem, 5 to the power 4 into 6 to the power 4. Here the bases are different but the powers are same. Then we need to use the fifth law of exponents. When the bases are different and the powers are same, then we need to multiply the bases. That is 5 to the power 4 into 6 to the power 4 equals to 5 into 6 whole to the power 4. That equals to, here we have used the law of exponent, a to the power m into b to the power m equals to a into b whole to the power m. Then it will become 5 6 30 whole to the power 4. This is the answer of the given problem. So these are the problems related to the laws of exponents for the real numbers. So by this concept the chapter number system finishes. So in the number system chapter, so far we have discussed about that is real numbers, then converting the real numbers in the p by q form, then we have received representation of a root 5 on the number line, then representation of root 9.3 on the number line, then laws of exponents for real numbers, and along with that one we also discussed the rationalization of irrational numbers. So these all are the concepts that we have covered in the chapter number system. Thank you.